Hi, I am Pulkit and I will be presenting on my final project, MongoDB, another popular NoSQL database. We will start with a brief introduction about MongoDB. We will look at some of its features and drawbacks of it. I'll go through the process of setting up a replica set consisting of 3 nodes and will explain the role what each node plays in the replica set. Then we will compare the terminology of MongoDB with respect to RDBMS, how some terms in MongoDB map to some of the terms which we are all familiar to in the relational world. We will execute some create, read, update operations on the newly created replica set to get familiarized with the commands used in MongoDB. Then I'll explain how I plan to use MongoDB to do some of the analysis on data available from GitHub archive. We will try to look at some of the query support available in MongoDB and also use the aggregation framework to see the capabilities of it. I'll finish off by giving a brief introduction on sharding, a mechanism to scale horizontally in MongoDB by adding more machines to the cluster. Look at some of the features that MongoDB provide. MongoDB is a NoSQL database which uses bson for storing the data internally. It provides a rich JSON support for insert, update, and query operations. It is a non-relational and non-transactional database. It does not have any support for joins, but it allows heterogeneous records to coexist in the collection. This is one of the most important features in MongoDB. It allows use of very rich document model where we can embed JSON objects or lists inside a document, pretty much like we do in object-oriented programming. MongoDB is highly scalable. As I mentioned earlier, there's a concept called sharding wherein we can add more replica sets to an existing cluster to scale the system to multiple hardware. Some of the unique and distinguishing things in MongoDB are the geospatial indexes. Uh, what these indexes basically do is, like, given a latitude and a longitude, we can say give me all the point of interests between a particular circular radius or some polygonal shapes. It also has a unique feature of TTL indexes. TTL indexes helps the data to auto purge once the time is expired. Basically, whenever we are inserting a record, we specify a date, and whenever the system crosses that date, the record is automatically deleted by MongoDB. It also has one of the features like capped collections, which are nothing but a fixed sized collection. This can act as a queue as well. Basically, any new record coming into the system, it keeps on adding to the collection, and the moment the size is hit, it starts overriding the previous one. It also has inbuilt support for MapReduce, and it also has a plugin for Hadoop wherein MongoDB can be used as a persistence layer for different Hadoop jobs. Let us look at the steps needed for setting up a replica set. First of all, we need to go to mongodb.org website and we click on download MongoDB. And we download the platform specific binaries from this website. We untar it, and what I have done is I add the path of the bin folder to my path, the environment variable, so that I can access the different MongoDB utilities without having to specify the path of them in my environment. One additional thing what I have done is I have added an alias called mongohost in my etc host file, and the IP address which I have given is the localhost IP address 127.0.0.1. This is because when we decide to add more members to a replica set, it doesn't allow us to add members using localhost, and the port number, and I did not want to specify my machine address in the scripts, so that if anyone wants to set up a replica set on their machines, the script which I have, it will just work out of the box. So over here I'm creating a 3-node replica set. So let us look at some of the properties for configuring each node in a setup. So these are the conf files for each of the node. The very first property, the replica set name, it can be any name, but this name has to be specified on all the 3 nodes. The second property, the DB path, is where the data folder will be created. Each node will has its own database folder wherein it writes the data. Third property is basically the log path. Again, it has to be different for all of the 3 nodes. Then I have specified the storage engine as WireTiger. This is one of the new engines which has been introduced in MongoDB version 3.0.x. This basically, prior to 3.0 version, there used to be a database level locking which used to happen for every write. Now they have got it down to a row level locking, which has considerably increased the performance of MongoDB. The last parameter is the port number. This port is where each server looks up for the incoming connections. Since I plan to run all the 3 nodes on my laptop, I had to give different port numbers here. So there is a setup required for creating all the directories, and I have a script for that. So this is the package which can be downloaded as part of this project. We will see different scripts here. So I'll first of all run the create dir this script. So what basically it does is it creates the data folder, the logs folder, and inside the data folder it creates one additional folder for storing the data of each of the MongoDB nodes. So let's run the script to start the replica set. So what this script basically does is it first brings each MongoDB node individually, one by one. So it has just started the MongoDB processes on port 2901 and 29020. And once all the 3 nodes are up, then it connects to the MongoDB instance running on 29019 and it initiates the replica set configuration command, which is rs.initiate. What this command rs.initiate does is it looks at the shard, the replica set name which we have given for in the configuration file, and it seeds that configuration. So what it has just done is it has added the node running at 29020 on this replica set. I mean, it generally takes, like, each process takes some time, because whenever a MongoDB process is added to the replica set, it has to create some journal files and all those things. I mean, some internal data structures for MongoDB gets initiated. That takes some time. So let's connect to MongoDB running on port 29019. This is the command to connect to that. So we have connected to that. Let's see if there are any databases already created there. So there are no databases there. The local database is one of MongoDB's internal, I think, which it uses for storing oplog, which is used for syncing the data between the primaries and the secondaries. So let's go back to the presentation now. So terminology. So how MongoDB uses some words differently than RDBMS. So a table in RDBMS ecosystem is maps to a collection in MongoDB. A row is referred to as a document. A column is referred to as a field. In RDBMS, we generally used to have joins between tables. MongoDB promotes using of embedded documents, which we will also see later on when we use the GitHub archive data, that how nested documents uh, look like. Then the aggregation operators, where group by in RDBMS word, they, I mean, MongoDB has most of those features. I will be using MongoDB to analyze data available from GitHub archive. GitHub is a free web-based Git repository which is used for distributed source code management. GitHub archive allows access to archived event data from GitHub public repositories. So let us look at GitHub archive once. So this is the website and it's openly available, and over here they have mentioned some of the APIs or some of the commands which we can fire to extract some data out of GitHub and GitHub archive. So let us try to download this data. Just exit this shell and we can use curl, and let me give the same name here. Okay, so that was fast. Now this is a gzip file. We can use unzip to unzip the file, and let us open this file. So this is basically a JSON record which we have got from GitHub archive. So we will use the Mongo import utility to import this data into the file, and after the import is done, we will try to answer some questions like logins having maximum number of associated events, most active projects, maximum forked projects, and how we can use MongoDB to store trends of every repository. So I want to analyze the data for 3 days. There are almost like 1.9 million records. It takes roughly 8 minutes to import. So I have a similar setup. Basically, I'll close this environment and I'll start in the same replica set environment which already has imported data. So we just looked at how we can download the data. Now just to let us execute one import command and how we can import the data in using Mongo import. So what we do is we use Mongo import --port 29019. This is the port of the primary. All the writes, they by default have to go to the primary, and then we specify the DB and the collection name. So let us say DB is GitHub demo --, the collection name we will say archive, and we will say import all our data in the JSON file over here. Okay, so it has imported 11,000 records. So let us connect back and let us see if the data has been imported. Okay, so it has created a database GitHub demo. Let us connect to this database. Let us see the collections in this database. Let us see the count. So this also has 11,000 records. Let us see how an individual record looks like. So GitHub archive gave us a data as JSON, so it was easy for us to import it here. Over here what we see is like for each of the record MongoDB has itself generated an underscore ID, which is the primary key. So the structure of each record, there is a field called type. There are roughly like 20 plus event types in GitHub. Like there are some like commit events, comment events, fork events, etc. For each record, there is also a field called actor. This is basically the credentials of the user who has executed this operation. There is also a nested object called repo, which is the repository against which the action has been done. And additionally, there is a field called date, which we will be using for running some of the analysis. And some records may have payload and some may not have payload, which we'll also see as part of this demo. So let us exit over here. So now I'll move to the setup where I already have all the data imported. I will kill my all the current MongoDB processes running here. I will move to another environment and I will run a script to start off the processes there. So basically what I am doing over here is I will be starting each and every process manually through the command line and not through the script. So this is done. Let us start the second one. Let us move the third one.